every electric vehicle begins with an invisible force. Not software, not batteries, magnets. Deep inside millions of electric motors are powerful rare earth magnets made from materials like neodymium and dysprosium. These magnets make modern electric vehicles incredibly efficient, compact, and powerful. But there's a problem. Nearly every major automaker depends on a global supply chain that is concentrated in only a few regions of the world. Mining is expensive. Processing is complex. Prices fluctuate. Geopolitics can disrupt supply overnight. What if the world's most important electric motor no longer needed permanent magnets? That question has inspired engineers around the world. Now, an Indian deep tech startup claims it may have found an answer. Electric motors appear simple. Apply electricity. The shaft rotates. But inside every motor is an invisible conversation between magnetic fields. In a permanent magnet synchronous motor, permanent magnets on the rotor interact with a rotating magnetic field created by the stator. This synchronized interaction creates smooth torque, high efficiency, and exceptional performance. But permanent magnets are also expensive. What if engineers could replace them, not with another material, but with software? Instead of placing permanent magnets inside the rotor, Vimag Labs claims it creates something called a virtual magnet. Rather than storing magnetic energy inside rare earth materials, the rotor contains copper windings. These windings receive electrical power wirelessly. Advanced control software continuously adjusts the magnetic field in real time. The result, according to the company, is a motor that behaves like a permanent magnet motor without permanent magnets. If successful, this would represent a major shift in electric motor design. Traditional wound-field motors often rely on brushes and slip rings to transfer electricity into the spinning rotor. These components wear out over time. Vimag Labs proposes replacing them with a rotating transformer. The stationary stator transfers electrical energy across a small air gap into the spinning rotor without physical contact. The rotor then creates its own programmable magnetic field. No brushes, no slip rings, no permanent magnets. Only electricity, software, and precision engineering. If this technology performs as claimed, its impact could extend far beyond electric cars, robotics, industrial automation, heavy transportation, defense, renewable energy, even aerospace. Removing rare earth magnets could reduce costs, simplify supply chains, and allow software to optimize motor performance continuously. But every breakthrough must survive one final test. Reality. Every technological revolution begins with one impossible question. Can we do it differently? For over a century, electric motors have relied on magnets. Now, engineers are asking whether software can create the same invisible force. Whether Vimag Labs becomes a global success or simply inspires the next generation of innovation, its work reminds us that the future belongs to those willing to rethink the fundamentals. The next revolution may not be louder. It may simply be magnet-free. What if the next revolution in electric mobility isn't a new battery, but a completely new kind of motor? The story of Vimag Labs and Volektra reminds us that the greatest innovations often begin by challenging ideas we once believed were impossible to change. Whether this magnet-free motor becomes the new global standard or simply inspires the next breakthrough, one thing is certain: the future of engineering is being written today. If you enjoyed this documentary, don't forget to like, share, and subscribe to Flying Art World for more cinematic stories exploring the technologies shaping our future. What do you think? Could software truly replace permanent magnets in electric motors? Share your thoughts in the comments below. Thank you for watching, and I'll see you in the next documentary.